Hey geometry class, this is our lesson on 6.6 and we're going to be looking at something called similarity transformations. And what that is something that we've studied before called dilations. We're going to be looking at dilations of figures and points on graphs, and what we've compared to what we've studied before, we've looked at figures and how they are similar to one another, and we've figured out their scale factors. Well, we're going to be given a scale factor, and we're going to be using coordinate geometry and performing dilations with our scale factors. And you'll see what I mean whenever we go through this lesson. So let's go and get started. To get us started on what dilations are, let's look at this exercise here. It says for each point, give the coordinates of a point twice as far from the origin along the ray from the origin 0, 0. So for point, what we see A saying 3, 5, let's go ahead and put that on our graph here, 3, 5. So there's a dot right there for, I'm going to label that A. And it asks us to graph a point or plot a point that is twice as far away from this point right here that I just graphed from the origin. So we kind of have this invisible line here that we're going to graph a point twice as far away. And it's going to be somewhere about along this graph right here, this line I just graphed here. So how we're going to do that is, well, twice as far away from 3 is 6, and twice as far away from 5 is 10. So let's graph the point 6, let's see, 6, 10, right here. That point right there. Okay. And if you have a piece of paper, you can line up the origin, the point A on there, and our new point 610, and they should be on the same line. And that is how a dilation is going to be also. You're going to have that ray going from the origin, and that you'll learn that's called our center of dilation in coordinate geometry is the origin right there. Let's go ahead and do this for B also, the point -2, 0. A point twice as far away from that, whoops, sorry guys, will be, let's see, this is B. Point twice as far away from -2, 0 will be right here at -4, 0. And again, how I got that is I multiplied 2 to both of these values here. And again, it is on the same ray. From the origin. Now let's do C. So 1/2, -1/2. Here's our point right there for that. And I'm going to label that C. And then point twice as far away from that would be if we multiply 1/2 by 2, we get not 2, but 1. And then -1. So that's the next point I'm going to plot right here. And again, they're going to be collinear along that same line from the origin through those points. All right, so let's take a bigger look at what dilations are and other sorts of definitions. So a dilation is a transformation that changes the size of a figure but not its shape. The preimage and the image are always similar. The things that we've been studying before, similar figures. So in a dilation, a figure is either enlarged or reduced with respect to the fixed point called the center of dilation. And our center of dilation in coordinate geometry, as I've stated already, is the origin, point 0, 0. And a scale factor of a dilation describes how much a figure is enlarged or reduced. And for a dilation with a scale factor k, that is what our scale factor is going to be called, k, you can find the image of a point by multiplying each coordinate by k, as this statement says right here. So we are given the point AB, and our image from that is going to be k times A and k times B. And that's going to be our image, our new point from the original image. Okay, so let's take a look at an example. All right, so we've already looked at this a little bit, but coordinate notation for a dilation, you can describe a dilation with respect to the origin with this notation right here. So this is known as our pre-image, and this is our image after we have multiplied our scale factor to it, that is known as our image. Okay, in our scale factor, we can either have a reduction or an enlargement, and how we know we have a reduction is our scale factor is going to be between 0 and 1, like this example right here. This is our pre-image, and this is our image. And if we do this to all of our values, x and y values, what I'm about to show you here, I'm going to take the 1.5 here and compare it to 3 by setting up their ratio. So 1.5 divided by 3. We can do this same thing with our x values. It should equal the same thing. So 3.5 and divided by 7. What you should see here is they should be equal to each other, and all of these values should be equal to each other. And you'll see that this fraction right here will reduce to 1/2. Okay, and that right there is our scale factor. That's how we can find our scale factor when given points. And you'll see that right there, 1/2 is between 0 and 1. So our scale factor here is going to cause a reduction from our pre-image to our image. Okay, let's look at an enlargement. An enlargement is whenever your scale factor is greater than 1. And you can see here from our pre-image to our image that we can do the same thing that we did here. Set up our x value from the image to over the x value from our pre-image as this right here. And like I said before, all of these x and y values should have the same scale factor for it to be a true dilation. And let's see, that is going to be equal to 1/2, or sorry, not 1/2, 2. And then let's do this, 14 over 7. You can see 14 divided by 7, that's going to be 2. -2 divided by -1, again 2, and so forth. 12 divided by 6 gives you 2 again. So all of these numbers, it shows that we do have a scale factor of 2, which is greater than 1. So this tells us that we have an enlargement here. All right, here in our example 1, we are asked to draw a quadrilateral HIJK with the dilation of quadrilateral ABC, and it's given vertices for A, B, C, D. Use the scale factor of 2. So on this, we're going to use the scale factor and multiply in each and every x and y value that we are given here on all of our points for quadrilateral ABCD to come up with this quadrilateral here in our coordinate plane here. So A will correspond to H, and to get the values of H, we are going to multiply it, each of these numbers, x and y, by 2. So 4, 2. And we're going to plot 4, 2. Let's see, 4, 2 is right here. And we'll name that H. And then same goes with I, corresponds to B. And multiply that, we get 8, 2. So 8, 2 here, and J corresponds to C. Multiplying those by 2, get 8, -2. So 8, -2. And then lastly, we have K. That corresponds to D, and we get the point 2, -2 when we multiply this by 2. All right, and let's see, what does that give us? All right, now if you connect these, you can see that we have the same shape here, the same figure drawn. It's just, it got bigger. It's an enlargement, okay? And that's the only thing that happened to our shape here, is that it was enlarged. All right, example 2, same thing as example 1. We are given a figure here. It's a triangle with vertices ABC. And the image of a triangle ABC after a dilation with a scale factor of 1/2 is triangle DEF. And it's asking us, well, let's draw this image. Okay, so do the same thing. Use 1/2 as a scale factor to figure out vertices D, E, and F. So vertices D, E, and F will come from A, B, C by dividing each and every one of our x and y values by 2, or just multiply by 1/2. Dividing by 2 is the same thing. So you're going to get 2 divided by 2 is 1. 4 divided by 2 is 2. And then, let's see, let's go ahead and do B and C. 8 divided by 2, 4, and 2. 8 is 4, and then -2. So plotting those points on here, we get 1, 2. This point right here is D, and 4, 2, E, and 4, -2, F. And again, this is a triangle. As I've already sketched here, it's the same shape, but just became smaller, so it's a reduction. Okay, this last example I have for you, not so bad at all. It's actually something that we've already been doing in the last 2 examples. It just asks us to find the coordinates of LMN so that the triangle LMN is a dilation of triangle PQR with a scale factor of K. And we are given PQR's coordinates right here, and then our scale factor is right here. So we're just asked to find what are the coordinates of LMN. And to find that, L corresponds to P. So using this scale factor of 4, multiply x and y by 4. So we're going to get -8, -4 for the first one. And then corresponding to Q, we have M. Multiplying x and y by 4, we get -4 and 0. And then R corresponds to N. And multiplying scale factor of 4 again to 0 and 1, we get 0 and -1, get 0, -4. And we're done with that. That is how you're supposed to do problems such as these. Let's do one more. And we get, let's see, whoops, didn't mean to do that. L corresponding to P. If we multiply it by the scale factor of 0.4, if you prefer to deal with fractions, this is actually the fraction 2/5. So multiplying both 5 and -5, we get 5, 5 times the 2/5, we get 2. and -2. Our coordinate for M corresponds to Q. And multiplying 10 to 2/5, we get 4. And then -5 again, -2. And R corresponding to N, we get again 4 and then +2. And we are done. So hopefully this was easy for everybody to understand. We're not doing much except for multiplication here and then plotting coordinates on the coordinate plane. And that's about it for this section. So I will see you all in class and we'll look at this a bit more. Bye, everybody.